Okay, today we're going to talk about measuring timing, and we're going to use effective velocity terms to try to explain it as best I can in the simplest way possible. So let's look in the upper left. We've got a 95 mile an hour fastball equals 0.400 seconds. So 400 milliseconds is how long it takes a 95 mile an hour fastball to get to the hitting area. Okay, so let's take a look at what the other measuring tool that we'll use, and that is this clock in the upper right hand corner. If I bump it one frame, if I move the video one frame, that equals about 0.017 seconds. That's how long it takes for the camera to move one frame. So we're going to get all the way to 0.400 seconds. So this is the area that we're talking about. This is a 95 effective velocity mile per hour fastball. In other words, it's probably more like 90, but because it's up and in, he has to get the bat all the way to here to be 100% on time. Now, clearly he's not, and he's not because I've asked him to be late. I've asked him to try to hit this fastball all the way back here. Where he's really hitting it is about a click different from that. So one click is a tool. It's a measuring device. If we talk about how late is he, well, he's 1, 2, 3, 4 clicks late to being 100% on time to that pitch. In reality, he's 1, 2, 3, 4, 5, 6 clicks late because this is where he would have to get the barrel to in order to be 100% on time. That's a long time. But I want you to understand what kind of area we're talking about too. So let's look at what is the hitting zone. If you look at where his barrel's at right now, he could make contact way out here. He can also make contact way back here. So this is actually, this entire area is the hitting zone. So how big is that? Well, just to put that in perspective, this line is the length of his bat, about 33 inches long. So if we move that, we can see that this hitting area is almost 2 lengths of his bat long. In other words, the ball comes into the picture way out here, and this is a place that he could make contact. And then all along here, he can make contact. So in reality, the hitting area is enormous. It is far greater than what most people talk about, which is this little area up here where we're talking about making perfect contact. But to make really terrible contact, we have this entire area that we're talking about where it's possible to make contact with a given pitch. But there's only one point along this line that's 100% on time, and that is right here. That's when his barrel, it gets to the area at 0.400 seconds. Now, he's not getting there on time. Again, this is a drill that I'm asking him to be late. This is not him being late because he's not a good player. He's very capable of getting to this point. Okay, so let's talk about one more major factor, and that is how long does it take to swing the bat? And the measurement is a general way to look at it is his toe hits, and then his heel plants, and then the hands start coming forward. When the hands start coming forward, that's the initiation of the swing itself. So his foot's on the ground, and we're talking about 1, 2, 3, 4, 5, 6, 7 clicks to contact, 8, 9 clicks to be 100% on time to this pitch. So it roughly takes him about 9 clicks to swing the bat. A major leaguer is going to be quicker than that. I'm going to say somewhere between 7.5 to 8 or 8.5 clicks is where a major leaguer is going to be. But the point is that it takes time to swing the bat. 8 clicks is a third of the flight of the pitch. That is a long time. And if we take the ball back to the point where it comes into this hitting zone that we talked about, it's 1, 2, 3, 4, 5. Actually, one more if we were to hit this all the way back here. 6 clicks is how long the ball's in the hitting area. 6 clicks. That's almost a third of the flight of the pitch. Not quite, but think about that in terms of how much time the ball is in that area that you can make contact. So I'm hoping that this gives you a better picture when I say to you that the ball, a 90-mile-an-hour pitch, can be 95, but it can also be 85. He's hitting this pitch as though it's 85. He's hitting it at a time that is 83 miles an hour right now. 0.46 is in that 83, 82 mile an hour range. So he's taken a lot of speed off of this pitch by hitting it this deep. That's what he's trying to do in this drill. But my point is that effective velocity helps us understand that speed is really relative. It's all about reactionary time and distance. And so if he were to hit this on time, he would have had to start 9 frames ago. He'd have to be at about 0.267 seconds or so in order to be able to be on time. Again, I'm asking him to be late, so he's getting his foot down late on purpose. But he would have to have it down right now in order to be able to have a chance to be on time to this location. So we've covered a lot of stuff, and this is a complex subject matter. But what I really wanted to make simple today was the idea that the ball travels, and when we use video, a click is a point in time. Now in this case, this ball is not really going 90 miles an hour or 95. It's a batting practice simulated pitch. It's a shorter distance. So in one frame, the ball is taking 0.17 seconds, is 0.017 seconds, and it's traveling about a foot. In reality, if it's going 95 miles an hour, it would be here and then all the way to about here, or about 2.3 feet in that 0.1 or 0.017 seconds. I know that's getting a little bit crazy because what we see right here is it's traveling a foot in that time. But in reality, it would be traveling 2 feet. But that's a huge area. That's a gigantic amount of time. As we can see, a lot goes on in each one of those clicks. 23.5 clicks at 95 miles an hour, 26.5 clicks roughly at 85 miles an hour, and 28 clicks at 80 miles an hour. So we're talking about time. Every one of these is time. But this is the contact point if he were going to be 100% on time. He's very late by design, but nonetheless very late. This is where he needs to get the bat to, and that's a long ways away from where he's actually at. But hopefully this will help you to understand a little bit more about time and about effective velocity.